Good day, grade 12s. Today we'll be looking into work, energy, and power, a topic we have within our syllabus for physical sciences. So let's quickly go through the exam guideline, which will now give us the main objectives of this topic. So firstly, we'll deal with work, define what is meant by the work done on an object, then draw force diagrams and free body diagrams, then calculate the work done on an object, then distinguish between positive and negative work done on a system. Then later on, we'll look into what we call the work energy theorem, a very important theorem. Then you must be able to define that work energy theorem in words and also be able to identify it in the data sheet, which we'll talk to later on. Then we are going to apply the work energy theorem on the objects that are moving horizontally, vertically, and also on the inclined planes, including the frictionless and rough surfaces. Later on, we'll also look into the conservation of energy with non-conservative forces present in that system. Firstly, we'll define what is meant by the conservative force. Then secondly, define what is meant by a non-conservative force, then state the principle of conservation of mechanical energy, then later on solve conservation of energy problems using that given equation there, which we'll talk to later on. Then use the relationship above to show that the presence of non-conservative forces in mechanical energy is conserved. Then later on, talk to power, define what is power, also look into the formula of power, make calculations based on the above formula, then perform calculation using another formula for power, which we'll talk to later on, and then calculate the output for a pump lifting up a mass. To the definition of work. We use the term work in everyday conversations or context to mean different things. We talk about going to work, doing classwork, doing homework, or working in a garden. However, in physical sciences, we use the term work to describe the process of transferring energy from an object or a system to another, or converting energy from one form to another. So let's look into the definition that we have here, which we will use to describe the term work in terms of physical sciences. So work done on an object by a force is the product of the displacement and the component of a force that is parallel to the displacement. So what does that mean? It means now for work to be done on an object or a system, the net force that is acting on an object must be parallel to the change in displacement of that particular object. So let's look into work in a mathematical sense. So mathematically, work, it is given as follows: W, capital W, it is equals to F multiplied by delta X multiplied by cosine theta, where now W is the work done on an object and it is measured in joules. Therefore, we should take into consideration anything that is measured in joules. We know that it is energy, or it can be measured in Newton meters, meaning now the work that is done on an object, basically it is the energy. Then F is the magnitude of the force that is acting on an object, and as we know, the force is measured in newtons. Then we have the change in displacement or change in X, which is the magnitude of the displacement of the object, and we know that displacement, it is measured in meters. Then again, we have theta, which is now the angle between the force and the displacement of the object. What is important to note again is to say work is a scalar quantity, and a scalar quantity basically it only has a magnitude but no direction. So whenever you're calculating work, remember we are dealing with energy. Then energy does not have any directions, but it has a magnitude including its SI units, which in this case for work are the joules or Newton meters. Then again, we should understand that the amount of work that is done by force is equal to the energy transfer taking place. In other words, the work done on an object, it is equal to the energy that is transferred into that particular system or an object. Now let's look onto what does work include or must include. We know that work, it involves the following. Number one, a force which acts on a certain object or a system, and we know the force that is given as F. Then also the displacement of that particular object, which can be given as either delta X or delta Y, depending on the direction of that object. Then let's look at this first box that we have here. So as we apply a force onto an object, the force it is going to cause that object to move over a displacement. Hence here we have change in X or change in displacement, and that is due to the applied force. So whenever now we have a resultant force and is applied to an object, the resultant force accelerates the object across the distance or the displacement delta X. Furthermore, we can say work is being done to increase the kinetic of an object. As we had observed earlier, this particular box was initially at rest, then after the force was applied to it, it changed displacement over time, meaning it has increased in terms of its kinetic energy. Then if an object experiences a resultant force in a vertical direction, then that particular applied force in the vertical direction, it is going to lift the object through the change in Y, which is in this case the vertical displacement. So we can say the work is being done to increase the potential energy of an object. So let's observe there. Initially we had our box at this position, then a force was applied to it, then as the force was applied to it, it changed in terms of its position above the ground level, meaning now it has increased in its potential energy. How to determine the angle for cos theta? Remember, theta is the angle between the force and the displacement of an object. Therefore, any force that is acting in the direction of the displacement, the angle between the force and the displacement itself of that particular object is going to be 0 degrees. And we know from mathematics, cos 0 degrees, it is equals to 1. So this is the same as when we are to calculate the work done on an object. We are going to have our general formula of W is equals to F delta X cos theta. Then whenever now we have the force being in the same direction as the displacement, then we are going to substitute our theta here with 0. Then we are going to have positive F delta x. And that is very important. We'll talk to it later on when we are dealing with different types of work done. Specifically this one, it has to do with the positive work done on an object. Furthermore, for any force that is not in the direction of the displacement, the angle between the force itself and the displacement of that object is going to be 180 degrees. And thus, mathematically, we know that cos 180 degrees, it is equals to -1. Therefore, whenever now we are to calculate work for a scenario where you have the force being applied in the opposite direction of the displacement, for theta, we are going to substitute with 180 degrees. Therefore, you are going to get negative F delta x, which is our displacement. Now, the negative work that we have there, we'll deal with it later on. However, again, we should note the following. Whenever now you have an angle that is greater or equal to 0 degrees and less than 90 degrees, for that particular angle, we are going to be transferring energy into the object or into the system. Then again, whenever now you have an angle which is greater than 90 degrees but less than 180, less or equals to 180 degrees, then in that case we are going to have the removal of energy from that system or object. Okay, let's look into positive work done on an object in which the applied force is in the same direction as that of the displacement. So here we have two cases. The first case, it has to deal with a person pulling an object in the same direction of the displacement. Then the second scenario, we have a person pushing an object in the same direction of the displacement. So these two instances or cases, they are similar in such a sense that they have an applied force that is applied in the same direction of that of the displacement. Therefore, what we should understand is that a force that is in the direction of the displacement does a positive work on an object. And whenever now we have a force and a displacement being parallel to each other and are in the same direction, again we say positive work is done on that particular object. So remember now, if we are to talk to an angle between the force and the displacement, in both of these cases our angle or theta, it is going to be equals to 0 degrees. Therefore, it means again a positive work is going to be done in this case, because remember Whenever we are to calculate work, we use the following formula. W, it is equals to F delta X cos theta. And in our case, remember, whenever now you have an angle being in the same direction as that of the displacement, our angle there is going to be 0 degrees. So for theta, we are going to substitute with 0 degrees. Therefore, we are going to remain with F delta X, and that is positive. And remember, if now our answer is positive, again it implies that we are doing positive work, and again positive work means that the energy is added into the system itself or the object itself. And thus, when now these objects move from A to B, in both of these cases, it means now the energy increases. And what type of energy increases? It is the kinetic energy of these two objects or these two scenarios. So that's it on positive work. What you should recall is that the force is in the same direction as the direction of the displacement of the object, and again the force, it is parallel to that is parallel to the displacement, and again the force that is applied on this object does positive work, meaning it adds energy into the system, and in this case the type of that energy is the kinetic energy. Positive work done by a force acting at an angle to the horizontal. Remember, the force doing the positive work on the object, it must be in the same direction as the displacement of our object, and our displacement in this case is that particular delta X, and our applied force, it is the force that is being applied by this man here. So if now the force now, which is the applied force in this case, doing the work, it is acting at an angle to the horizontal, you must firstly determine the horizontal component of the force acting at that particular angle. So in this case, what would be our horizontal component for the applied force? It is going to be given as Fx. And why are we going to ignore, in this case, Fy, or the vertical component? It is because we are dealing with the work that is moving in the horizontal plane. Hence, we'll focus on Fx. Now, how are we going to go about writing now this particular horizontal component of the applied force? Is that we are going to use our trig ratios, and we understand from trigonometry that Fx in this case, it is going to be equals to the force applied multiplied by cos theta. And remember, theta being the angle between the applied force and the horizontal itself. So how would we go about now making calculation? Is that we are going to use the horizontal component of the force to determine the amount of work. And how do we go about that? We'll write the usual formula as it is, which is in this case going to be F, in fact W, it is equals to F delta X cos theta. And here for theta, they are going to be specific. There's an angle which you are going to be given, and that angle is the one that you are going to take and substitute with it for that particular theta. And the answer that we are going to get, of course, is going to be positive. Why is that the case? That is because we understand to say for this given angle here, as we can see, it is between 0 and 90 degrees. So it means for this instance, where a force is being applied at an angle to the horizontal, then it means again we are doing positive work, meaning again this object, it is going to gain energy, or energy is going to be added into it. And which type of energy? It is of course going to be the kinetic energy. Now let's look at the negative work done on an object. Remember, whenever a force is in the same direction as the direction of the displacement, in that case we are talking about positive work. However, if you have any force, for example in this case you have a frictional force which is acting on this object as it moves through the displacement from A to B. As that object experiences the frictional force, what is going to happen there is that we can clearly see that the frictional force is in the opposite direction of the displacement, and as a result the angle between the applied force and the displacement is going to be 180 degrees. And remember, the 180 degrees gives us what we call a negative value. Hence, when we substitute on this formula, W it is equals to F delta X cos theta, specifically in this case the F being the frictional force, we are going to get a value which is negative, because we understand to say cos 180 degrees, it is equals to negative 1. Hence our work is going to be negative F delta X, meaning we would have done negative work on that particular system or an object. And let's keep in mind the following: whenever now you have the force acting in the opposite direction to the displacement, the object, it is going to decrease in terms of its energy, meaning the negative work does the following: it removes energy from the system or the object itself. Then this energy that is being removed from this system, it can come or be distributed in the following forms. It can come as some sort of the heat that you'd get on the surface, or it might come as the sound energy. And again, let's emphasize on this: the negative work, what does it do? It decreases the energy in the system, meaning the energy is removed out of the system. Now, for zero work done on an object, whenever now you have any force, be it the normal force or the force of gravity, or any force component that is acting perpendicular to the direction of the displacement, that type of force, it is going to be doing what we call zero work. Why is that the case? Now remember, from mathematics. In this case, whenever we say two things or two lines are perpendicular to each other, it implies that they're at an angle of 90 degrees to each other. So whenever now we have an angle of 90 degrees between the applied force and our displacement, now that means that cos theta, it is going to be equals to cos 90 degrees, and cos 90 degrees, it is equals to 0. Then whenever now we are to make our calculations based on this fact that cos 90 it is equals to 0, we are going to write our formula. SW, it is equals to F delta X cos theta, and in our case our theta, we know it is 90 degrees, and anything multiplied by cos 90 degrees, the answer there is going to be 0 joules, meaning whenever now we have an angle of 90 degrees between the force applied and the displacement of an object, then in that case we are basically doing 0 work on the object, and 0 work means that there's no energy that is transferred or removed from the object or the system itself. Let's look into the work done on an object that is at an incline. So the first thing that we should take into consideration are all the forces that are parallel to the incline itself. And what are those forces? They are our applied force, the frictional force, and the FG parallel. So we are going to ignore the normal force and also the FG perpendicular. So these two forces, we are going to ignore them because they are perpendicular to the object. And remember, if they are perpendicular to the object, it means they form an angle of 90 degrees and they do not do any work on the object. So the only forces that are doing work on the object is this applied force, the FG parallel, and also the frictional force. So let's start with the applied force. So this object, it is being pushed upwards the slope. Then it means it is going to move upwards the slope, and the applied force in this case is in the same direction as the direction of the displacement, meaning now the angle between the applied force and the displacement is 0 degrees. Then how would we go about calculating work for the applied force? We'd say work applied, it is equals to the applied force multiplied by the displacement cos theta, and our theta, remember in this case, is going to be 0 degrees. Then secondly, we are going to calculate the work that is being done by the frictional force. So if we check, the direction of the frictional force is acting in the opposite direction to the direction of the displacement, meaning the angle that exists between the frictional force and the displacement, it is equals to 180 degrees. Then we are going to write the work done by the frictional force equals to the frictional force multiplied by delta x cos theta, and our theta in this case, it is going to be that 180 degrees. Then lastly, we are going to calculate the work that is being done by the FG parallel. What we should note is that we should simplify the FG parallel into mg sine theta. The theta of sine there, it would be the angle that forms an incline there. Then we are going to multiply that mg sine theta by our displacement cos theta, and cos theta, this particular theta, it also is equal to the 180 that we had for the frictional force. Why is that the case? It is because we know that the FG parallel force, it always acts downwards the slope. So if an object, it is pushed upwards, then it means our FG, it is going to be acting downwards. And again, if our object, it is being pushed downwards, still our FG parallel, it is still going to be acting downwards the slope. So remember, the theta that we have here, it is the angle of the incline. Then the theta that we have there, it is basically the direction of that particular FG parallel, of which it is opposite to the displacement of our particular object. So this is how you would go about calculating each respective work that is done by each force that is there on an object that is moving at an incline. Alright, now let's look into the work done vertically on an object. Let's assume now that an object that is lifted up from point A up to point B. As it is being lifted up, of course, it is going to be lifted up by an applied force in an upward direction. Then it is going to again change in displacement in a vertical direction, which is in this case upwards. And as we can see in this case, both the displacement and the applied force are in the same direction, and that means, of course, positive work is going to be done on this particular object as it is being displaced or moved from point A to point B. Again, what we should take into consideration is that as this object, it is being moved up, in some instances we are going to be given a scenario where in which now you have the frictional force acting on an object, and that frictional force, in this case, it is going to be acting downwards. And this frictional force, they would tell you probably to say it is the air friction. Then again, what you should take into consideration is that for any object that it is moved vertically, of course, it is going to experience what we call the gravitational force. And we know that the gravitational force, it is given as mg, which is, of course, the mass of an object multiplied by its gravitational acceleration of 9.8 meters per second squared. then it means you are going to be having three forces that would be acting on an object. The first one being, of course, the applied force, the frictional force, which is caused by the air friction, and of course the force of gravity. So how would you go about calculating work for each respective force that is there? So the work done by the applied force is equals to the applied force multiplied by the change in displacement, and in this case, of course, it's going to be y instead of x. Why is that the case? It is because our object is moving vertically, and our theta in this case, it is going to be theta equals to 0 degrees. Why is that the case? It is because the applied force and the displacement are in the same direction. Then secondly, we are going to look into the work that is done by the frictional force. So we are going to say the frictional force multiplied by delta y cos theta, and in this case our theta is going to be equals to 180 degrees. Why is that the case? It is because always the frictional force opposes the intended motion of an object. So our theta there is going to be 180 degrees. Then lastly, we are going to calculate the work that is being done by the gravitational force. So we are going to have here Fg, which of course can be also expressed as mg delta y cos theta. And again, our theta in this case, you check the direction of the force of gravity. We know it always acts downwards. So if an object is displaced in an upward direction, then it means our Fg is going to have an angle of 180 degrees, which we are going to substitute there whenever now we are calculating work for the force of gravity.